In this video, we are going to talk about radical functions, or more specifically, square root functions. The first thing we're going to consider is what the domain of radical or square root functions would be. So for instance, on this problem, if you have f of x equals the square root of 3x plus 8. When you're talking about the domain of the square root functions, the radicand, which is what is underneath that square root symbol, cannot be negative. So the way that we're going to say that is that the radicand has to be greater than or equal to 0, because that's how you are not negative, right? If you're less than 0, then you're negative. But I need the radicand to be not negative, so I need it to be greater than or equal to 0. So you just set up whatever your radicand is, in this case 3x plus 8, and say that needs to be greater than or equal to 0. And then solve it for the x. So subtract the 8 from both sides here. So now I have 3x needs to be greater than or equal to negative 8, and then divide by 3. So your x needs to be greater than or equal to negative 8/3. Okay, now let's look at what these look like on So what I'm going to do on these are all going to be multiple choice to where you are looking at a square root graph. So on this case, I have f of x equals 4 square roots of x. So I'm just going to put this in my y equals. So I have 4, and then second square root x. So let's look at what this looks like. That's what your square root graph is going to look like. It's going to have a starting point, and the starting point is going to have to do with the domain, okay? Because remember, the radicand, which in this case is just the x, has to be positive. So it has to be greater than or equal to 0. So that's why when you're looking at this graph, you can see it starts at the origin. It starts where x is 0. And then let's look at a couple more points. So I'm going to go to the table. So second table, and look at some points. So it starts at 0, 0. Look what happens in your table when your x is less than 0. You get those error messages because the graph simply does not go to where the x's are negatives. So I have a point at 0, 0. A point at 1, 4, and a point at 4, 8. So it starts at 0, 0. And then there's a point at 1, 4. So to the right 1 and up 4. And then to the right 1, 2, 3, 4 and up 8. So I need one more little hash mark. So to the right 4 and up 8 to draw the graph. So when you're looking at these, you'll notice what I like to do. Let's look at this one. So you'll notice that the scale, if the right end of the x-axis is showing as a 10, that means that each one of those lines is 2s, going by 2s, 2, 4, 6, 8, 10. So make sure there's a point at 0, 0, and then a point at 1, 4. So to the right 1, and then up 4. When you do that on this graph, when you go to the right 1 and up 4, since the hash marks are going by 2s, you're going to be right in the middle of going between 0 and 2, and then up to the second line for the y to get that 1, 4. Okay? Now, let's look at what the negative does in front of that 4 on this next kind of problem. This one you have f of x equals negative 4 square roots of x. So on this one, when I put this in my y equals, let's look at what that does to it. So negative 4 square root x. So what that did is it turned it upside down. In other words, it reflected it across the x-axis. So when I graph this one, if I need some points, it's going to start at 0, 0 again. And then 1, negative 4, and 4, negative 8. So you'll notice that when you plot those points, so again, it starts at 0, 0, to the right 1 and down 4, and then to the right 4 and down 8. So again, when you are looking at these, make sure that you see that the x and y axes, they're, again, the lines, the in between lines is going by 2s, 2, 4, 6, 8, 10. So that's why it'll look a little different than what I'm drawing and what's in your calculator, simply because their scale is going by 2s. Okay, here's another example. F of x equals the square root of x minus 5. Now this one you can really use the idea of the domain to help you, because remember the radicand, which is x minus 5, has to be greater than or equal to 0. So when you add the 5s to both sides, this is telling you that x is going to be greater than or equal to 5. In other words, it's going to start where x is 5. Okay, so look at this D option. It looks like it's starting at 1, but again, this time the scale is going by 5s, because you'll notice that right part of the x-axis is saying 20. So if I start at the origin and get to that 20, each one of those lines is going to be 5 for 5, 10, 15, and 20. So, and that's where it starts, where the x is 5.